Good morning, everyone. Okay, I hope the homework you have completed. What is a geometric interpretation of a partial derivative, and what is the slope of a tangent, and all these basic concept you have studied. Hello. Yes, have you studied the basic concepts? I have told you to find out what is OD, why there is need to introduce a PD, and then what is your OD in which a derivative we call as a slope of a tangent. The next thing we call it as a rate of change, right? Slope of a tangent, or we can call it as a rate of a change of a function f. What is PD? Yes. Have you gone through the geometric interpretation of a partial derivative? आवाज येते माझा सगळ्यांना? हॅलो.
Yes, ma'am. Yes, ma'am.
Okay. I hope you have done it. Let us go for the next one, that is a directional derivative. Okay, what is a directional derivative? Actually, directional derivative you have seen already in semester 1 paper of real analysis in the somewhere in the third and fourth chapter, right? So let us start with what is a directional derivative. Actually, the concept of a directional derivative arises due to the fact that there is some of the drawback in your partial derivative, right? So partial derivative means what? What we are doing, the partial, the name itself suggests the meaning. What you do? Firstly, we keep suppose three variables are there, then y and z we keep as it is, and we take the derivative with respect to x, right? Then after that we keep x and z as it is, then we take a derivative with respect to y, and so on, right? Many number of terms may be there. Suppose they are x1, x2, x3, up to so on xn terms are there. So you can take the partial derivative with this also. Okay. So actually, we again come back to ordinary derivative itself, because at a time only we are finding the derivative with respect to at least one variable, right? First we find the derivative in x direction, then y direction and z direction. Correct? Now, what is there in the directional derivative? We can find the rate of change in arbitrary direction. Or we can say we can find out the derivative of a function in arbitrary direction. Right. So if we want to find out the rate of change in arbitrary direction, that is called a directional derivative. The name itself suggests the meaning that directional means the what? If suppose you want to find out the derivative with respect to partial derivative, right? So you want to at least find out either in x, y, or z. But in between them, if suppose I want to find out the rate of change in this direction, or if I want to find out the or your derivative in this direction, that means in between x and z. Suppose if I want to find out in arbitrary direction, right? So it is not possible to find out in the partial derivative. Barabar?
Yes, ma'am.
Okay, if it is not possible, so that's why we have introduced as the concept of a directional derivative, that we can find out the rate of change of the derivative of a function in a arbitrary direction. So for that, let us go with the definition first. Whatever the definition you have seen in your real analysis one, it is very similar, but there is some difference in the notations. So let us go for that first one. Let f be the real valued function defined on E3 space, B a differentiable real valued function on E3, and let Vp is a tangent vector to E3. Let Vp is a tangent vector . in E3, then we write the derivative, then directional derivative, or we can call it as a then the number. What is a number? We are going to denote the directional derivative as square bracket derivative of this function f and in the direction of a tangent vector vp. Actually, it should not be capital, so it is we can write it as vp f. Derivative of function f in the square bracket denotes that we are finding the directional derivative in the direction of a tangent vector v at a point p, right? Which is given as d by dt of, right? That is initial rate of change of a function. Initial, that t equal to 0, rate of change, the d by dt, rate of change of a function f at a point p in the direction of a v. Okay, so the number which is denoted by this one. Now how the it is read as vpf. Vpf means what? Directional derivative of a function f at a point p in the direction of a v, right? Which is given by initial rate of change of a function. Initial rate of change. First one, this comes initial rate of change of a function f at a point p in the direction of a vector v. Okay, so how to define this? VPF is a directional derivative of a function f at a point p in the direction of v, right? Rather, we come it as a initial rate of change. Initial rate of change of a function f at a point p in the direction of a tangent vector v. Okay, so for what is initially we are provided rate of change of a function we are going to find out in arbitrary direction. That is what the main concept of your directional derivative. हमें अब तक arbitrary direction में कोई भी rate of change नहीं find out किया है, correct no? येते का find out करायला rate of change arbitrary direction मध्ये either we find like this, no? Either we find d by dx, dy by dx, or we find df by dx, or we find df by dy, z. So we are finding in either x, y, or z direction. But if you want to find out in arbitrary direction, we are provided with one function f. We have to find out the derivative of this function at a point p in the direction of a v. Okay, so how the concept of a, now one may have a question where you are finding the rate of change in arbitrary direction, right? अभी तक हमने जो भी स्टडी किया है, so the derivative we are writing like this f dash of c, and what is the derivative? It is nothing but limit as h tends to 0 f of c plus h minus f of c divided by h. ऐसी just देना definition first principle. Yes, no. So here you can see c plus h and c, इन दोनों का difference लेते हैं ना हम लोग. Difference in y coordinate divided by difference in x coordinate and limit as h tends to 0. This is f dash of c. But here it is f dash of p plus tv. Like f dash of c plus tv. What is this v? V ensures that we are going in the arbitrary direction. Okay. So if you have a question that where we are finding in arbitrary direction, right? So because we are also finding the derivative at a point p in the direction of v means what? This that in the direction of v ensures that we are finding the rate of change in the arbitrary direction. Any doubt for this definition? Okay, let me repeat once again. What is a definition? It is going to find out the rate of change in arbitrary direction. So for that, first we need one real valued function defined on E3 space, that is f. Okay, and what is a notation? Vp square bracket f, and how it is read? Vpf, right? So it is this square bracket denotes that we are finding the directional derivative function f at a point p in the direction of a v. So what is the definition? Initial rate of change of a function f at a point p in the direction of a v. 1, 2, 3, 4, 5 ऐसे क्यों लिखा है मैंने? Because we are reading like this only, no? Initial rate of change. d by dt means rate of change of a function means your function f at a point p म्हणजे हे fourth one, and then in the direction of a v. So if someone asks you that where you are finding in arbitrary direction, so in the definition itself we can show that Up to now, whatever we are finding, it is f dash of c, but here it is f dash of c plus tv. That means at a point p in the direction of a v. So this direction v ensures that we are finding the rate of change in the arbitrary direction. Okay.
Yes, ma'am.
Yes,
Okay,
ma'am.
let us go for the example. I hope you are also writing these examples. Try to understand the example. Calculate VPF for the function. Calculate VPF means directional derivative function f at a point p in the direction of v, or the function f is equals to y square z with the point p. What is a point p? 2 0 minus 1, and v in the direction of v means what? 2 minus 1 3. I hope everyone go through this uh, notes that I have shared you on the classroom itself. बघितलेत का notes differential geometry चे? Yes, have you seen the notes of differential geometry that I have shared you on the classroom itself? Am I audible to everyone? Hello.
Yes, ma'am.
So what we have to do, we have to find out the value of a directional derivative of a function f at a point p in the direction of a v. So let us go by one. So what is the definition? VPF, directional derivative function f at a point p in the direction of v is given by, it is given by initial rate of change of a function f at a point p in the direction of a v. So first we have to find out what is p plus tv, correct? So let us go for the solution. What is there in the solution? First we will find out what is p plus tv. T is any some scalar, no? Which is lying in some particular interval, right? Parameter we can call. Okay, so P is given to you. What is P? 2, 0, minus 1 plus T. Value of V is also given 2 minus 1, 3. Okay, try to solve it with me only so that you can understand what you are solving. Okay, and what is the value of this one? 2 plus 2T, then minus T, then minus 1 plus 3T. So this is what your value of a P plus TV. Okay, then what is the value of f of P plus TV? For that, firstly we should know what is your function f provided. Okay, what is the function f provided? Y square into z. If function f is y square into z, so what you have to do? You have to square of y and into this z. Correct? Getting me what I told you? So this is what the y coordinate and this is z. Your function is y square into z. Correct? So if it is y square into z, you have to f of p plus tv मध्ये जे काही तुमचा y आणि z coordinate आहे. So you have to minus t square y square into z. Z means minus 1 plus 3t. Okay? So this is what t square into minus 1 plus 3t. What is the resultant of this one is minus t square plus 3t cube. Correct? So this is what your f of p plus tv, you have got it. Correct? समजतंय सगळ्यांना? Any doubt?
Yes, ma'am.
Okay, so we have found up to this one, f of p plus tv. Now what is the next job? We have to find out the derivative, and after that you have to put t equal to 0. बरोबर? Okay, so we have found up to f of p plus tv, right? So next what you have to do, d by dt of f of p plus tv. This is what your f of p plus tv. First we find p plus tv, then we find f of p plus tv. So whatever may be the coordinates of p plus tv, you have to write down your function f, okay, first, and then see what is x, y, z in your p plus tv, and accordingly you have to write down f of p plus tv. Okay, let me find out the derivative with respect to t. What is the derivative of this one? It is minus 2t plus 9t square. Now what we have to do, we have to substitute t equal to 0 so that we can find out the initial rate of change of a function f at a point p in the direction of a v. Correct? So what is the value? After putting t equal to 0, it will be completely equal to 0. So what it means? What do you mean by this one? That is VPF is equal to 0 means what? Your directional derivative of a function f at a point P in the direction of V is equal to 0 means what? Your function is constant. Correct? Barabar na?
Yes, ma'am.
F dash is equal to 0 means what? F is equal to constant. So here also we get the directional derivative in particular with some p and value of v, then we got the value it as a 0. Now everyone, if you have solved this example, I will change the value of v, because if I change the value of v, we have to see what is the effect. Okay, just now we got in the direction of v in at a point p, we are getting the value of a directional derivative as a 0. So which means that your function is constant in the direction of v at a point p. But if suppose I have changed the value of this one as, say, suppose 1 minus 1 0. Try to evaluate this. If you have solved the example, if you have written this, try to evaluate and tell me the answer. What is VPF, that is directional derivative function f in at a point p in the direction of a v, by considering v equal to 1 minus 1 0 and p is whatever we have written initially. Okay, have you understood what you have to do? समजला का काय सांगितले? हॅलो.
Yes, ma'am. Repeat.
Hello, anyone else having a problem?
No, ma'am.
लिहिलेत का तुम्ही example?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, try to solve it. Okay, this is what the example I have solved you. What you have to do, same example you have to write. VPF you have to calculate. F is given to us. F पण same आहे, P पण same आहे. फक्त direction V change केले. Right? VPF चा formula आहे आपल्याकडे. Just now we have seen the definition. What you have to do, first you have to find out P plus TV. Then find out F of P plus TV. जे काही P plus TV चे coordinate असतील, तिथे F function बघून ते coordinate use करायचे. Correct? Next, you have to find out derivative. After finding the derivative, put t equal to 0, which means that your function, derivative of your function, rather we can say that directional derivative function in the direction of v at a point p is 0, which means that your function f is constant. आता change काय करायचे? As it is, whatever you have function f, p, everything is same. But what is a change? The direction I have changed it. Okay, let us see what is the effect after changing the direction. Okay, initially we have found function is constant because your directional derivative we have found it 0. आठवतंय ना सगळ्यांना? डेरिव्हेटिव्ह 0 असेल तर फंक्शनला कॉन्स्टंट म्हणतो ना?
Yes, ma'am.
Yes, ma'am.
Okay. Try to solve and tell me fastly.
0 येते, ma'am.
Again it is
Yes,
0?
Ma'am, 0.
Okay. So just now what you have to do, you keep a function f as it is. Now we will change both one. That is, we will change the vector part as well as a point of application. Okay. So what we will do, we will keep it as 1, 2, minus 1. Then we will have the point P as 4, 1, and we will keep this as suppose minus 3. Okay, take a function f as it is and again find out the p plus tv, f of p plus tv, then find out the derivative, vpf. Okay, सगळ्यांचा आन्सर 0 आला होता का?
Yes, ma'am.
Yes, ma'am.
Ma'am.
Okay.
Yes, ma'am.
Yes, do it for the next different points of application and vector part.
-3.
Minus 3. Yes, everyone got the same answer. VPF is minus 3.
Yes, ma'am.
Is there any problem for solving these type of example?
No.
It is very easy. The derivative which we have solved in 11th or 12th standard, उससे भी बहुत ज़्यादा easy है यहाँ पे. P plus T evaluate करना है. Then just find out the derivative with respect to T and then put T equal to 0. Okay. So from this, what you understand? Firstly, we got the 0. In the second one, we got the answer again 0, and then third one, we got the answer is minus 3. Okay, but this is not possible in the ordinary derivative. Why this is possible here? Because we are changing the point P as well as we are changing the direction vector. Okay, so in that particular point P and the direction vector D, we are getting value for directional derivative either 0 or some another number. Okay, so what do you mean by that number? Whatever you got, it is minus 3. By this rate of change, your function is changing. Correct? या rate of change ने तुमचा function change होणार आहे. Correct? Now let us go for the one more example. Z is equal to e raised to x into cos phi, and P and V are same. Whatever there for the example 1. P is equal to 2 0 minus 1, V is equal to 2 minus 1 3. Okay, first you have to find out P plus TV, then you have to find out F of P plus TV, then you have to find out the derivative of F of P plus TV, that is d by dt of F of P plus TV. Correct? Then put t equal to 0. Evaluate and tell me the answer.
मॅम ह्या अगोदरचा आन्सर -3 येते.
नहीं -13 येतो.
-12 आले मॅम.
That's why I asked you, no? She told me minus 3, so I asked every student whether you got the same answer.
नो मॅम.
हो मॅम -12 येतो.
हां.
-12 येते मॅम.
बाकी अजून -13 पण म्हणलेत ना काही जण. Yes. How many of you got the same answer -12? ओके, जो जिसका नहीं आया -12 उन्होंने फिर से एक बार चेक करो कि वेदर यू आर हैविंग सम calculation mistake. Okay, let us go for solving this one. P plus TV 2 0 minus 1 plus t times v is equal to 2 minus 1 3. Then what is the value of P plus TV? 2 plus 2t minus t, then it is minus 1 plus 3t. F of P plus TV का येणार आहे e raised to x. So what is your x coordinate? E raised to 2 plus 2t into cos y means what? Cos of y, that is minus t. Correct? Yes, what is cos of minus t?
minus cos of t.
कॉस ऑफ टी.
Cos is positive, no?
यस मॅम.
Yes,
That's
ma'am.
why cos of minus t is cos t. Correct? Next, you have to evaluate the derivative. As e square is a constant, we can keep outside e raised to 2t as it is. Derivative of cos is minus sin t plus, right? E raised to 2t, derivative of e raised to 2t is 2 into, and then cos of t as it is. U into v rule we have applied. Now just put t equal to 0 for this one, and what you get the answer is e square, e raised to 0, sin 0 is always 0, plus e raised to 0, then into 2, cos of 0 is 1. So you get the answer is 2e square. And we can say that by this number of, at this rate, your function is changing, correct? At this rate, your function is changing because this is what your value of a directional derivative. You can write the statement at this rate, the function is changing because derivative in the sense what it is rate of change of a function. I hope you remember one of the thing that you have done this is as f dash of cu somewhere in your real analysis paper, which is written as limit as h tends to 0 f of c plus hu minus f of c. असंच लिहिलं होतं ना डेरिव्हेटिव्हचे
Yes,
डेफिनेशन
ma'am.
डायरेक्शनल डेरिव्हेटिव्ह. Okay. Let us go for the one theorem related to this directional derivative. Rather, we can say another definition for your directional derivative. What is another definition for the directional derivative? Is that uh, we have to first make a use of our given definition. With the help of that, we are going to derive one formula, or rather, we can say it is a relation between directional derivative and partial derivative. Okay, because actually, whenever you come to the directional derivative, we are very not easily able to find out the rate of change in arbitrary direction. No doubt, it is able to see that in by solving the example, it is easier. But if suppose someone want to do it actually practically, so it is somewhat difficult. So that's why we have got the relation between the directional derivative and partial derivative with the help of this theorem, or we can say another definition for your directional derivative. Okay. So what is the statement of this one? If v is a tangent vector, we have been provided that let v be the one tangent vector with the coordinate v1, v2, v3 in E3 at a point P. Okay, V is a one tangent vector in E3 at a point P. Then prove that. What is our aim to prove that? VPF is equals to summation over I Vi dou f by dou xi at a point P. Correct? This is what your VPF is equals to summation over I Vi dou f by dou xi. Now what is the proof? In the proof, we have to write down what is given to us. What is given first, initially we are provided with one tangent vector v1 with the coordinates say v1, v2, v3. Okay, and what is again we are provided? We are provided with one arbitrary point. So that arbitrary point I have selected as say with coordinate p1, p2, and p3. Okay. Now, in the similar way, whatever we have done for solving the example, what we have done for solving the example, if P and V are given, what we have done, P plus TV we have found. Is it okay?
Yes, ma'am.
क्या करना है हमें यहाँ पे स्टेटमेंट में क्या दिया है V and any point P in the E3 space is given. And what is our aim to prove that? We have to prove that VPF can be written as summation over I Vi dou f by dou xi. एक्चुअल डेफिनेशन क्या है इसका डी बाई डी टी ऑफ एफ ऑफ पी प्लस टी वी एट अ पॉइंट और इन द at t equal to 0. Now your directional derivative definition you can see here. This is what VPF is directional derivative which is equal to dou f by dou xi. What do you mean by dou f by dou xi? Dou f by dou x, dou f by dou y and dou f by dz. Is it okay?
Yes, ma'am.
What is this dou f by dou x, dou f by dou y and dou f by dou z? काय आहे कुठे ऐकलात का?
Rate function in x, y, and z direction.
That is nothing but your partial derivative. Now the notation dou is a notation for partial derivative. So you can say we are finding the partial derivative function f in the direction of x, y, and z. So you can see here the directional derivative we have written in the linear combinations of the partial derivative. Okay. So that's why I told you that this is what the theorem which gives you the relation between the directional derivative and the partial derivative. Getting me what is given to us and what we want to prove. दिया हुआ क्या है हमें? V and P. 2 points are given and we know the definition. Okay, by using the definition itself or whatever the example we have solved just now. What you have done for the example, first you have to find out P plus TV, then you go for f of P plus TV, then find out the derivative with respect to T, which gives you the value of a derivative, right? Here also we have to do very similarly, but what is a change? V और P आपको दिया हुआ नहीं है यहाँ पे. It is arbitrary one. V is with V1, V2, V3 and P is with P1, P2, P3. Any doubt for this one?
No, ma'am.
Okay, what is P plus TV? We have to evaluate this as P plus TV is equals to P1 plus TV1, P2 plus TV2, P3 plus TV3, correct? This is what P plus TV. Now what is f of P plus TV? Whether a function f is given to you.
No, ma'am.
So how you are going to write down? This is what f of, we can say it is Pi plus TBI, correct? Or you can write down in detail also what is f of P plus TV, which is equal to P1 f of P1 plus TV1, then f of P2 plus TV2 and P3 plus TV3. So this one I have written in a compact form for I equal to 1, 2, 3. Okay. F of Pi plus TVI. Right. What is the next step? We have to find out the derivative. For that, for what we will do, first this Pi plus TVI we are going to fix out. We will write down this as f of xi. What is your xi now? This is what xi is equal to Pi plus TVI. Any doubt up to this step? Very
No.
easy and simple step we are following, whatever we have done for the example. Yes, if you are having any doubt for solving the example, you can ask. Except how to find out the derivative, because this is already done how to find out the derivative. Because इससे भी complicated derivative हमने solve किया ना 11th 12th standard. Composition and division का भी हमने solve किया है, substitution method. Here we are finding very easy derivatives, right? The main concentration in this paper is we are going to find out the main properties of your curve surfaces, that is tangent, binormal, normal, all these properties we are going to see in this paper, correct? So here we are provided, firstly we will find out P plus TV, then f of P plus TV, then as we don't know what is Pi and Vi, so that's why we will name it as some xi is equal to Pi plus TVI. So what will be your f of P plus TV? It is f of xi. Now what is the next step? We have to find out the derivative, correct? By definition. Definition मध्ये काय आहे? First you find P plus TV, f of P plus TV, then find the derivative at t equal to 0. So df by dt. What will be df by dt? Can anyone give me the derivative? F is a function of xi is a function of a t now. Correct? So here we are going to use a partial derivative, that is dou f by dou x1 and dx1 by dt. Why I am writing the total derivative dx1 by dt? Because xi's are function of t only, but your f is a function of x is a function of t. Correct? F is a function of xi is a function of t. So if it is involving two independent variables, we are writing the partial derivative. Is it okay?
Yes, ma'am.
Dou f by dou x2, derivative of x2 with respect to t, plus similarly f with respect to x3, then derivative of x3 with respect to t. Yes, what is dou f by dou x1? derivative of a function f with respect to x1. Can you find this unless and until you are knowing a function?
No,
माहिती आहे
ma'am.
function?
No,
हां.
ma'am.
So now what is dx1 by dt? x1 आहे तुमच्याकडे. We are finding the derivative of xi with respect to t. काय असेल x1 with respect to t? This is what
P1.
x1 is equal to p1 plus tv1. What is dx1 by dt derivative of x1 with respect to t? p आणि v काय असणार
V1.
आहे? They are constant terms, no? Derivative with respect to t. इथे काय येणार आहे 0 plus derivative with respect to t1 into v1 as it is. Correct? What are p1, v1? These are simply the coordinates. Right? No? Just like in the example we have seen. What is p? Coordinates of p and v? These are simply your real numbers. So what is the derivative of those constant terms? These are 0. But derivative v1 as it is, derivative with respect to t here 1 it is. So x1 with respect to t is v1 plus what is x2 with respect to t?
V2.
This one as it is. Why this one as it is? Because we don't know the function. And again x3 with respect to t is v3. Then f with respect to x3 as it is. So we get df by dt is equals to, I can write now in the summation form. Summation over I vi v1 v2 v3 dou f by dou xi, and hence the proof. Okay. Now, if you are finding this at t equal to 0, it ensures that this is what your VPF. Sorry, it is small one. VPF is equal to summation over I vi dou f by dou xi, which ensures that your directional derivative is nothing but the combination of a partial derivative. That means directional derivative means what? We again go back to your partial derivative, but it is a linear combination. Okay. In this theorem, we have studied that directional derivative is linear combinations of the partial derivative. Just like we have done for xyz, or xyz can be written as x at u1, y u2, and z u3. What are u1, u2, u3? These are nothing but your bases, no? Basis of R3 space. Here also, these dou f by dou x, dou f by dou y, and dou f by dou z will work as a basis while finding your directional derivative. बरोबर ना? v1 v2 v3 काय असणार आहे? From the example itself you can see what are v1 v2 v3.
Yes.
These are some numbers, real numbers. So that's why here also we have the real numbers, no? While finding the basis में क्या लिखते हैं हम? Linear combination ना, c1 v1 plus c2 v2 plus c3 v3 is equal to 0. What are c1 c2 c3? These are some constant number. So here v1 v2 v3 will work as a constant number. Dou f by dou xi, dou f by dou dou f by dou y, dou f by dou z will work as a basis whenever you are going to find out the directional derivative. That's why this theorem ensures that your directional derivative is a linear combinations of the partial derivative. Are you getting what I told you? No doubt that this concept or this paper is completely different for you people. We haven't seen any basic ideas about this one. So that's why I'm going very slowly so that you can understand every point. Okay, this time please don't do that whatever you have done for your um, second semester, first semester, because we feel it that in your oral exam no one is able to answer the very easy question. What the questions were asked for you? I asked you limit point definition and some of the definition from the topology and all, and madam asked you the field extension, right? These easy questions should be answerable, right? No, हे तर आम्ही कुणालाही विचारत नव्हते. इवन फॉर ओरल एक्झामिनेशन वी अपॉइंट वन टू external examiner from either Nanded or Pune or something else, right? You can ask your seniors and all. They might be your senior or their senior, right? So be a knowledgeable person at least, because we are after passing this exams we are master of science or master in mathematics, which means that at least we should know some of the basic definitions of mathematics. Okay, so what we have done in this lecture, we have started with the definition of a directional derivative. So what is a directional derivative? It gives you a rate of change in the arbitrary direction where we are provided with one function f at a point p in the direction of v. So what is a derivative? It is initial rate of change of a function f at a point p in the direction of a v. Up to now we are writing this as f dash of c, but now it is with v. That v vector ensures that we are finding it an arbitrary direction. And we have gone for the example. What we have to do for the example, first find p plus tv, then find f of p plus tv, then find out the rate of change, put t equal to 0. Okay. So in the very similar way, now we have seen in the relation between the directional derivative and the partial derivative. Now one may have a question, what is a geometric interpretation of a directional derivative? Actually, it was a homework for you people to find out the direction, sorry, geometric interpretation of a partial derivative, right? Okay, let us go for the directional derivative geometry interpretation. What is given to us? We are provided with one function. Suppose that function is with c variable, just like we have written for z is equal to e raised to x into cos y. So this is some function in your 3D space, right? So in that, for what we firstly find, we find the p plus tv, correct? We find first p plus tv. For that, what you have to do, we have to find out firstly. Suppose here is some point P and here is your vector V, P plus V. I hope everyone knowing the definition of tangent vector VP. We have written the definition as P to P plus V it is, and it is denoted by V to the suffix P. This is what the definition of a tangent vector. It has two things. First one, point of application. Second one is a vector part. Okay. So here somewhere in between P and P plus V, we can get P plus TV. समझते हैं? Any
Yes,
doubt?
ma'am.
Okay. Somewhere in between P and P plus V, we will get P plus TV where T is a parameter which will lie in some particular interval. I hope you are knowing the difference between the constant, parameter and variable. Parameter and variable are very similar, but parameter only lies in the particular interval, but variable can vary in the whole real line. Constant म्हणजे ते value fix असणार आहे. Okay, so in the very similar way, whatever we have found here, so f of p plus tv I can plot here, correct? Because your function f is there in the 3D space, right? So now you can find out the derivative of this function, because simply what you have to do here, you have to find out the rate of change d by dt, and hence you can get this here in the form of a derivative. Okay. Actually, there might be some internet issues. From up to where we you were there in this meeting, कहाँ तक हो गया था? हेलो हेलो
हाँ मॅम इथपर्यंत झालं होतं.
we were discussing the geometric interpretation. No, so what is a geometric interpretation? P and P plus V are provided. Somewhere in between them, we can get P plus TV. So here we get image of that point P plus TV. We can plot here as f of P plus TV. Now it remains to find out the derivative. So it is easy to find out the derivative, and here it will be a slope of a tangent. Now let us go for the solving the same examples which we have solved with the help of a definition. Now we will solve with the help of a formula which we have seen. What is the formula? Summation over I vi dou f by dou xi. Right? F is known to you. First we will find out the derivative. What is dou f by dou x? 0. Dou f by dou y 2yz. Derivative with respect to z is y square. What is v1, v2, v3? These are nothing but your v1, v2 and v3. Correct? Written this. So what is v1? 2. F with respect to x is 0. Plus what is v2? It is minus 1. F with respect to y is 2yz. Plus what is v3? It is 3. F with respect to z is y square. Okay. So what is the resultant? We have to find out this as minus 2yz plus 3y square. But we have to find out the value of this one at v. What is the value of v in the direction of, sorry, at a point P we have to find out. What is our point P? 2 minus 1, 3. So we have to evaluate the value at P equal to 2 minus 1, 3. Right? Minus 2 into. What is the value of y? Y is minus 1 into z is 3 plus 3. What is the value of y? Again minus 1. It's a square. So what we get the resultant? 9. Sorry. What is actually we somewhere, what is a point P we are provided? 2 0 minus 1 है ना? Point P is 2 0 minus 1 and V is 2 minus 1 3. So here I have used that. Sorry. Here it is 2 minus 1 3. This is what your V1, V2, V3. But we have to evaluate this at point P. Okay, so put up the value of here minus 2 into what is the value of y? It is 0. Plus 3 into what is the value of y? Again it is 0. So resultant is 0. You can check back which we have done with the help of a definition. We get the value of directional derivative 0 there. Here also we got the same value. Okay. Let us do for the same thing of example 2. PPF is equal to summation over I vi dou f by dou xi. For that we know the function f. What is your function f given to us as e raised to x into cos phi. Okay, what is the derivative of a function? First we will write down v1, v2, v3. What is your v1 plus what is your v2? v2 का आया है minus 1 plus what is the value of v3? It is 3. What are your v1, v2, v3? These are coordinates of your point or a vector v. 2 minus 1, 3. Okay. Next, what is the derivative function f in at with respect to x is e raised to x cos y as it is. Derivative with respect to here it is e raised to x as it is. Derivative with respect to y it is minus sin y. With respect to z it is 0. So what we get the resultant? Now we have to evaluate this at a point p equal to 2 0 minus 1. Okay. So 2 into e raised to 2 cos y means cos of 0 plus e raised to 0 into sin 0 का INR है 0 plus 0. So we get the answer as 2 e square, and hence you can get, we have got the same answer from the formula as well as from the definition. Which one you feel easier, either go by the formula or you can go by with the help of a definition. Any doubt up to this one?
No, ma'am.
हाँ, आहेत का कुणाला doubt?
No, ma'am. No, ma'am.
If not, we'll in the next lecture we will go for the properties of the directional derivative. What do you mean by properties of the directional derivative? We will see all the properties which we have seen for the derivative. Okay, directional derivative की properties में क्या आएगा? Firstly, for the derivative, what we have seen, if f and g are two functions, then derivative of this function is evaluated by df by dx plus df by dg by dx. If it is product of two function, right, derivative if you want to evaluate, what you do, f as it is derivative of g plus g as it is derivative of f, correct? So these type of a formula we will see with the help of a directional derivative, right? Whether the same formula or what is the effect of directional derivative on these one, on the addition, on the multiplication, right? What is this multiplication rule? We call it is Leibniz rule for the differentiation, correct? So these type of properties we are going to see in the next lecture for the directional derivative. Up to then, what you do, you complete your first homework, that is geometric interpretation of a partial derivative. Secondly, you again go back to the derivative and see the properties. Addition के लिए क्या है, multiplication के लिए क्या है, अगर सब्सट्रैक्शन है तो वहाँ पे कैसे रूल अप्लाई करते हैं. If it is scalar multiplication, then how we do the derivative, correct? So try to go with these rules, and then in the next lecture we will see what are the rules or the properties of a directional derivative. That is, we will see Leibniz rule, then we will see linearity in a tangent vector and linearity in a function. Okay, if you have a doubt you can ask, otherwise we will end the lecture.